We are going to look at some of the highlights of probability. First of all, a few terms. Outcomes are the possible results. Like if you roll a die, you have 6 possible outcomes. 1, 2, 3, 4, 5, 6. Each of those are called an outcome. A full collection of outcomes. Sorry that that's misspelled. Once I saw that earlier today, I couldn't take my eyes off of it, and it really bothers me that it's misspelled. 1, 2, 3, 4, 5, 6. That collection is called an event. The event would be rolling a die. The set of all possible outcomes is called the sample space. This section in the book really wants you to focus on sample spaces. And this can be good for helping you understand kind of the logistics of probability, but it also can be fairly aggravating because writing out a full sample space can be a lot of work. So we are going to flip a coin and roll a 6-sided die. How many possible outcomes are in the sample space? List the possible outcomes. So if I flip a coin, I could get heads. I roll a die, I can get a 1. That's one possible outcome. Flipping heads and rolling a 2, that's another possible outcome. What's another one? H3, H4, and so on. There's flipping heads and rolling 1 through 6. We also have flipping tails and rolling 1 through 6. Once we write these all out, we can count them. There are 12 possible outcomes in this sample space. Now I want you to think for a minute. How many possible outcomes are there just for flipping a coin? 2. How many possible outcomes are there just for rolling a 6-sided die? 6. Can you take the numbers 2 and 6 and somehow come up with 12?
Yeah, multiply.
2 times 6 equals 12. What word is connecting these two things that I have underlined?
Possible or outcome.
The word and. The word and in probability means multiply. So if they're asking you to flip a coin and roll a 6-sided die, 2 times 6, there's 12 possible outcomes. So now let's use that to figure out how many possible outcomes are there of flipping 2 coins. So you got your first coin, which has 2 possible outcomes. And your second coin, how many possible outcomes does your second coin have? 2. Yeah, don't think about that too hard. And the word and means that we multiply. 2 times 2 means that there are 4 possible outcomes. Now let's list those outcomes. We can flip heads, heads, or heads, tails. What other outcomes are there? Tails, tails, and tails, heads. Some people would say that heads, tails, and tails, heads are really the same outcome, but in probability, you have to consider both of the coins as individual things. It's more likely to get 1 head and 1 tail when you flip 2 coins because there are 2 outcomes that give you that result. They are technically 2 different outcomes. Okay, I'm going to let you do number 3 on your own. So first I want you to figure out how many possible outcomes are there, and then I want you to list those outcomes. So pause the video, try number 3. Probability is the likelihood or the chance of something occurring. It is a number between 0 and 1. If I ask you, what is the probability of flipping heads on 1 coin? What would you tell me? 50%, right? 50% or 0.5 or 1 out of 2. Those numbers all mean the same thing. So probability is a number or a fraction between 0 and 1 that can be expressed as a fraction, a decimal, or a percent. A probability of 0 means it's absolutely not going to happen. Okay? The probability of me giving you $100 right now is 0. It's not going to happen. A probability of 1 or 100% means it's absolutely going to happen. There's a 100% chance of rain this morning prior to 7 p.m.? It definitely rained prior to 7 a.m. Did I say 7 p.m.? Wow. Can you tell it's 7th hour on a Wednesday? Yeah, definitely. It's Wednesday.
It's Wednesday, my dudes.
Wow. Okay, theoretical probability. This is a fancy way of saying the probability that you've been using ever since you learned even the littlest thing about probability. Theoretical probability is the number of wanted outcomes over the total number of possible outcomes. Okay, for example, if I wanted you to roll a standard 6-sided die and get a number larger than 1. How many things on that die are actually larger than 1? 5. 2, 3, 4, 5, and 6. There are 5 outcomes that we want out of a total of 6 possible outcomes. Now, here's kind of an easy thing to slip up on. If I ask you, what is the probability of rolling a 2? A lot of people see the number 2 and they write 2 over 6. Are there 2 ways to roll a 2? There's one way to roll a 2 out of 6 possible numbers on the die. So really keep track of the top number is how many ways that you can get what you want over the total number of things that you could get. Okay, on the next page, originally, the book gives you this chart and asks you to fill this in. This is one of those moments where you can't think too simply about probability. A student taking a quiz randomly guesses the answers to 4 true-false questions. What is the probability of the student guessing exactly 2 correct answers? It's not 2 out of 4. It's not 50%. It sounds like it could be, but there's more than 4 ways that you could answer this question. So if you get 0 questions correct, you could guess all 4 questions incorrectly. That's one way that you could answer the questions. You could answer 1 question correctly. You could get number 1 correct, number 2 correct, number 3 correct, or number 4 correct. If you're getting 2 correct answers, there are actually 6 ways that you can get 2 correct answers, 4 ways to get 3 correct answers, and 1 way to get 4 correct answers. So if you count up all of these, total, there are 16 ways that you could answer this question. So when you first look at this question, you're thinking 2 correct answers out of 4 questions. That's 2 out of 4. It's not quite that simple. There are 6 ways to get exactly 2 questions correct. So 2 out of 16. Now we're going to take our calculators, and I want you to write your answers as a fraction, a decimal, and a percent. So 2 divided by 16, that is 0.125. What is 0.125 as a percent? 12.5%. To change a decimal to a fraction, you move the decimal point 2 places to the right, or the other thing that you can do is multiply that decimal times 100, and that will give you your percent. Okay, we are going to change number 5 because I don't like it. Okay, I want us to flip a coin 3 times. What is the probability of getting heads 3 times? And I also just introduced a notation for you. If you see P parentheses and then there's some words written, that means probability of, and then whatever's inside the parentheses is describing what you're trying to find the probability of. So let's think about the first time that we flip the coin. What is our probability of getting heads the first time we flip the coin? 1 out of 2. The second time we flip the coin, what's the probability of getting heads? 1 out of 2. The third time we flip the coin, 1 out of 2. Could we say that we are trying to get heads and heads and heads? Would it make sense to use the word and in between these? If you can use the word and, you are going to multiply them. Here's what the book wants you to do with this problem. The book wants you to say, all right, well, we could get heads, heads, heads. We could get heads, heads, tails. We could get heads, tails, heads. We could get heads, tails, tails. They want you to calculate the entire sample space, all of the possibilities, and then count the number of times that you get heads 3 times. That takes a lot of work, so I'm going to teach you the shortcut at the beginning so that you don't have to do a whole bunch of extra work. Is that okay with you? The shortcut is, if you can use the word and, you multiply. And when you're multiplying fractions, you multiply straight across the top and straight across the bottom. So, what is 1 times 1 times 1? 1. What is 2 times 2 times 2? 8. 2 times 2 is 4. 4 times 2 is 8. So the probability that you get heads 3 times is 1 out of 8. And if we write 1/8 as a decimal, 1 divided by 8 is 0.125, which is 12.5%. Sometimes it's easier to count the things that you don't want. That's called the complement of an event. If I tell you that there is a 20% probability of rain on Tuesday, what's the probability that it's not going to rain on Tuesday?
60, 80.
80%. How did you get 80%?
Subtraction.
100 minus 20 is 80. That is finding the complement. So, if we look down at the bottom of this page, if I tell you that the probability of event A is 0.45, the probability of not A with a bar on top means not A, the probability of not A would be 1 minus 0.45, which is 0.55. If I tell you that the probability of A is 1/4, what's the probability that A doesn't happen? Don't think too hard.
4 times.
3/4. If 1/4 happens, 3/4 doesn't. If the probability that something's going to happen is 1, what's the probability that it's not going to happen?
0.
0. All right, let's look at this dice problem. I roll 2 6-sided dice. There are 36 possible outcomes. That's shown in this little picture. The probability that the sum of our 2 dice is not 6. There's a lot of things here that have a sum of not 6. It's going to be easier to count how many have a sum that is 6. Here's 6. Here's 6. How many did I just circle? 5 of them. 5 out of 36 have a sum of exactly 6. So how many out of 36 have a sum that is not 6?
5.
31 out of 36. The probability that the sum is less than or equal to 9. I'm going to count how many have a sum greater than 9. So there's 10.
No.
It would be these 6. There are 6 out of 36 that have a sum greater than 9. What is 36 minus 6?
35.
30.